Welcome to QuickBytes Education. Today's QuickByte is all about container runtimes, explained simply, quickly, and clearly. Let's get started. If you're studying for the KCNA exam, you need to know this. Kubernetes does not magically run containers by itself. Kubernetes schedules workloads, manages pods, and coordinates the cluster. But the container runtime is the software on each node that actually starts and runs the containers. So in this video, you'll learn what a container runtime is, why Kubernetes needs one, what CRI means, and how this shows up on the KCNA exam. Here's what we're covering today. First, we'll define a container runtime in plain English. Then we'll look at how it works with Kubernetes. Next, we'll explain CRI, Containerd, CRI-O, and Docker. And finally, we'll cover the exam traps that most beginners miss. A container runtime is the software responsible for running containers. Think of a container image like a recipe. It contains everything needed to create the container, like the application code, libraries, dependencies, and settings. But a recipe does not cook itself. The container runtime is like the kitchen equipment that turns that recipe into an actual meal. In Kubernetes terms, the container image is the template, and the running container is the live instance. The runtime pulls the image, starts the container, manages the container process, and helps stop or remove it when needed. On the exam, they may test this by asking what component actually runs containers on a node. The answer is not the scheduler. It is not the API server. It is the container runtime. Container image to container runtime to running container. That's the basic idea. The image is what you want to run. The runtime is what makes it run. The container is the result. Now let's connect this to Kubernetes. In a Kubernetes cluster, workloads run inside pods. A pod is the smallest deployable unit in Kubernetes, and it can contain one or more containers. Each worker node has an agent called the kubelet. The kubelet is responsible for making sure the containers described in the pod specification are actually running on that node. But the kubelet does not directly run the container by itself. Instead, the kubelet talks to the container runtime. So the flow looks like this. The control plane says, "This pod should run on this node." The kubelet on that node receives the instruction. Then the kubelet tells the container runtime, "Start these containers." The runtime does the lower-level work of pulling the image and running the container. On the KCNA exam, they may ask how Kubernetes runs containers across nodes. The key idea is this. Kubernetes coordinates the work, but the container runtime executes the containers. Quick checkpoint. So far, you've learned that container images are templates. Containers are running instances, and container runtimes are the tools that actually start and manage those containers on Kubernetes nodes. That's the foundation. Now let's talk about CRI. CRI stands for Container Runtime Interface. That sounds fancy, but the idea is simple. CRI is the standard way the kubelet talks to container runtimes. Without a standard interface, Kubernetes would need custom code for every runtime. That would be messy. Instead, CRI gives Kubernetes a consistent way to communicate with different runtimes. So whether a cluster uses Containerd or CRI-O, the kubelet can still communicate through the Container Runtime Interface. Think of CRI like a universal charger. Different devices may be built differently, but if they support the same standard connection, they can still work with the system. On the exam, they may test this by asking what allows Kubernetes to work with different container runtimes. The answer is CRI. The Container Runtime Interface. Now let's clear up a common confusion. You'll often hear Docker, Containerd, and CRI-O mentioned together. Docker is a platform that helped make containers popular. It includes tools for building, packaging, sharing, and running containers. Containerd is a container runtime that focuses on managing the container lifecycle. It can pull images, start containers, stop containers, and manage container execution. CRI-O is another container runtime designed specifically for Kubernetes and the Container Runtime Interface. Here's where most people get this wrong. They think Kubernetes always needs Docker. But modern Kubernetes does not require Docker as the container runtime. Kubernetes needs a runtime that supports CRI. So for the KCNA exam, focus less on Docker runs Kubernetes containers and more on this idea. Kubernetes uses the kubelet to communicate with a CRI-compatible container runtime, such as Containerd or CRI-O. That is the exam-friendly answer. So why does this matter? Because Kubernetes is all about orchestration. Orchestration means coordinating containers across multiple machines. But orchestration still needs something on each node that can actually run the containers. That is the runtime's job. If the runtime is missing, broken, or incompatible, the node cannot properly run pods. That means workloads may fail to start, containers may not run, and the node may not behave correctly in the cluster. On the exam, they may ask what needs to exist on every Kubernetes node so pods and containers can run. One important answer is a working container runtime. Here's what you just learned. A container runtime is the software that runs containers. A container image is the template. A container is the running instance. In Kubernetes, the kubelet talks to the container runtime to start and manage containers inside pods. CRI stands for Container Runtime Interface, and it gives Kubernetes a standard way to work with different runtimes. Containerd and CRI-O are common container runtimes used with Kubernetes. And the big exam takeaway is this. Kubernetes manages and orchestrates containers, but the container runtime actually runs them on each node. Like, subscribe, and keep building your knowledge with QuickBytes education, one QuickByte at a time.